Okay, let's go through together, right? How y'all feeling after playing the game? Tired? Okay, y'all look like calm. Just now was complete chaos, right? Everyone was not exactly complete chaos, but okay, it's good to see y'all lively. Yeah, holiday time. It's okay to play a few games. Who destroyed the street? Right, the street. Okay, come. Let's take a look at this question. Okay, part A. So Jared used the same plant T throughout the whole experiment. Give a reason why using the same plant helps to make it a fair test. Okay, we're going to start one by one. Okay, start from Ryan. What's the answer for first one?
By using the same plant, only one variable in the experiment is changed.
One variable. What do you mean?
Because if you don't use the same plant, there will be more than one variable is changed.
Okay, very good. So in this question, in this experiment, they're trying to find out if the color of the light will affect the number of bubbles produced. Okay, so so you have to say that when you keep the plant the same, when the plant is kept the same, the number of leaves remains the same, and hence rate of photosynthesis.
But sir, different plant can also have the same leaves.
Oh no, but the area is different. The area is different. Oh no, what happened to my letters? Okay, the number of leaves remains the same, and hence the rate of photosynthesis will be the same. Okay, or you can talk about the surface area. Now there are actually many answers for this, right? This is one particular answer. Now, what other answers do you have that you want to check? Okay, the type of plant also affects, right? What if you have like, two different types of plants? You can't use two different types of plants. It's just one type of plant. Okay, so the number of leaves, the type of plant, right, affects the rate of photosynthesis. Okay, next. So what can Jared do to increase the number of bubbles?
Intensity of light, increase the intensity.
Yeah, once again, many answers. Okay, one possible answer is to increase the intensity of light. Any more? Any other answers?
Place it outside.
Huh? Place it outside.
Because it says that it's placed in a dark room.
Light. Okay. So it's the same as increasing the intensity of light, right? Yeah. What else?
Use more white light.
Use more white light. How come? Why is it white light? Use more white light. Are you talking about increasing the intensity? Is it the same as increasing the intensity? No. Okay, see, you have to talk about increasing the intensity. Now, how to increase the intensity? You can bring it outside. Number one, use a stronger torch. Number two, bring the torch nearer. Bring the torch nearer, also can. So all these actions increases the intensity of light. Okay, so you can increase the intensity of light by bringing the light source nearer. Right, so this will increase the rate of photosynthesis, and therefore the number of bubbles will increase. Right, it's about increasing the rate of photosynthesis, and therefore the number of bubbles will increase. Next one. So Jared want to find out if the temperature of plant would affect the rate of photosynthesis for T. Of water will affect the rate of photosynthesis for plant T. So apart from using the same plant, suggest two other variables that must be constant.
The layer of oil and the intensity of
The what?
the layer of oil and the intensity of light.
Very good. Okay, the layer of the oil. Just name how many do you need? Two. Okay. So the layer of oil. Yes, very good. There are many answers again, right? the
Well, you talk about the oil.
layer of oil. Okay, what else?
Surrounding temperature.
Temperature. Okay.
Intensity of light.
Temperature.
Material or bigger pen.
Location. Material bigger. Not really. No, not really. Nope.
Amount of water used.
The light and color of the light.
Yes, intensity and
Yes,
color
it is.
of light. Alright, any other answers you want to check?
Amount of water used.
Can amount volume of water or volume of water. Okay, yeah, all these are acceptable answers, right? It's a long list of answers given. Okay, long list of answers. There are many other. Any others you want to check? No. Okay, so this is about the experiment. Okay, next. Oh, you have a copy. Okay, just choose any two. So this is about experiment for this particular section. Okay, next one, electricity. Okay, so which bulb will light up in setup 2? Setup 2 is the one below. Wait,
It looks like none of them.
W, X, Y, Z. Okay, so Katie set up the circuit, new bulbs and battery, connector for jack. So bulbs B1, B2, B4 lit up, while B3 did not. Now, if B3 did not light up,
That means Y is an
you can deduce that Y is a insulator.
I think Y is insulated, that means none of the box.
So now in setup 2, we put Y just after the batteries. That's where the electric current will be flowing.
That means
Okay.
the answer is none.
Yes, very good. The answer is none.
What?
Why?
Wow.
None. Why? Because Y. Okay, Y is a
It's an insulator.
insulator. Wait, let me expand this thing.
Extension and contraction.
The expanders.
Okay, Y is an insulator of electricity.
There's no electric current happening.
Yeah. Now, if you just put the word insulator,
Of what?
cannot, right? You have to say the insulator of electricity. Okay, it's being specified here. You have to specify Y is an insulator of electricity, and hence, yes, very good. And hence, it creates an open circuit. Right? So the idea is it's an open circuit, so electric current cannot pass through. So give an example of Y and Z. So many examples.
Why is toilet paper?
Toilet paper.
No, Y is paper.
Yeah.
Y is wood.
Wood can.
Glass.
Glass also can.
Why is a human head?
Human hair also can. Ryan, who are?
Right.
I'm looking at you, but I say his name. Okay. No, Sean. Sean's head. Okay. Sorry, not you. Okay, I was looking at him. Okay, what about Z?
Cobalt.
Cobalt. Okay, can. Metal. I'll just say metal. Metal. What? What? No, let's do a few more. Okay, so wood and metal. Okay.
So we go break then you come back and do some.
No, I do one more.
Be more refreshed.
We do two more until finish 38. Okay, next one. So beaker A was used as a control setup. Explain the purpose of the control setup in this experiment.
To see what would
To
happen.
demonstrate the purpose of the wet cotton wool in Baker B.
To demonstrate the what?
To,
The purpose of the wet cotton wool.
The purpose of wet cotton wool.
to see whether the wet cotton wool would affect the experiment.
To see whether you have to be more specific.
To ensure that the heat loss is only due to the wet cotton.
Correct. Okay, something like that. Okay.
I'm sure that the two setups are different.
No. I mean, then you don't need to put cotton wool. We can do something else. Now let me write it here.
What's the
Okay, so what is the purpose of the control setup? The control
I can see that.
setup helps to show that changes in the temperature.
The changes in the world.
What? What?
The thing. The changes in the temperature.
The temperature of the water
The White House.
is only due to
Of Washington.
the
The control helps to show that changes in Washington is only due to normal.
what are you talking about?
He said to ensure the change. That only
Okay, changes in temperature is only due to the layer of cotton wool. Right, that's the purpose of the control. So next one is explain how the layer of wet cotton wool help the water reach a lower temperature. Anyone? How come the wet cotton wool can help the beaker, the water in the beaker, reach a lower temperature?
Because of evaporation.
Okay. So of course you can't just say because of evaporation.
Just write evaporation.
You can't just write evaporation. The concept is correct, but you have to explain it properly. So what about evaporation?
It's spelled with an E.
Evaporation. Okay, what about evaporation? Now, how come the temperature will decrease? Why does the temperature decrease? It must lose something.
Lose heat.
Yeah, lose heat. Okay, so how come evaporation allows it to lose heat?
Because the heat is trapped in the water.
The heat is trapped in the water?
Because it doesn't gain heat.
No.
Because heat
How
is
does
Because
evaporation
heat
make
is
it lose heat?
transferred from the beaker to the
Yes.
to
Okay. The heat in the water is being transferred to the wet cotton wool, and when it evaporates, it removes the heat from the water. Okay. Let me write down. Okay, so the beaker, the water in the beaker B, okay, loses heat faster. Wait, let me look at C first, okay? Okay, never mind. So we have to explain everything here because C is a different question. Loses heat faster as heat is being removed Okay, so the idea here is that there is evaporation, lose heat faster. Okay, let's make it complete. Of the water in the wet cotton wool. Okay, the wet cotton wool, there's evaporation. Evaporation absorbs the heat, takes away the heat. So when the thing loses heat faster, temperature decreases faster. Okay, this is we've done this so many times. Right, every time evaporation is the same stuff, same things. So explain how this behavior helps the polar bear in keeping warm. Wow, we just see one black color patch of stuff. So the polar bear has a layer of fur
You
to
see
help.
one guy's face.
One guy's face.
You look like one guy's.
Who? Doesn't look like anything to me.
Abraham Lincoln.
Okay, so when a polar bear climbs onto dry land after a swim, it shakes its body to remove the water trapped in its fur, as shown. Okay, so it is removing the water trapped in its fur. Now, why does it keep the polar bear warm? Why must it remove the water in his fur?
Because
You freeze on the
is it because when the water evaporates, the polar bear loses heat as its heat was trapped in the water that had evaporated?
Yeah, it's about the evaporation. Now, if he has water which is trapped in his fur, when the water evaporates, it will remove heat from the body. It will remove heat from the body. Okay, that means
It's time for break.
no, let's finish this. So by removing the water from its fur, the polar bear prevents heat loss when the water evaporates. This keeps it warm. Okay, so you prevent further heat loss when the water evaporates. Right, so this particular question is just testing you on the concept of evaporation. Evaporation causes, yes, we're doing. Evaporation causes more heat loss. Okay, so we take a short break, 5 minutes. Okay, and then we will continue.